All right, good morning, everybody. So today we're covering lesson 4.5 on rational root theorems of polynomial functions. Now, what the heck is rational? Rational means that you have something divided by something. That's a ratio, right? Ratios are like one thing over another, like 2/4, like fractions, right? Then we have I'm going to make sure my microphone was on. Then we have this theorem with the rational root theorem. Roots, what do roots mean? Roots mean that these are like the x-intercepts, right? This is like if you have a graph, and let's say this is a cubic function, right? Let's say it goes like this, and you say, hey, what are the roots of this function? And you say, oh, the roots are here. Where are they? They're here, here, and here. These are the roots of the function. These are the zeros of the function. This is where the y value is equal to 0, right? It could be 5 right here. It could be -5 right here. But right here at this height, these are all 0. So that's why we call them zeros. It's where the graph crosses the x-axis. Perfect. Now let's cover the rational root theorem. This states that it's just a rule to help you find the possible roots of a polynomial. So let's say you have the function f of x is equal to, and this is number 1, x squared plus 8x plus 10. Then by the rational roots theorem, you would need to get all the factors of the constant and this works for any polynomial. Notice that this is a polynomial. I could have wrote it like this, p of x polynomial, just understanding that this function here is a polynomial, as you can see. This is a polynomial, right? It consists of multiple terms. Poly means many. So the rational root theorem, in order to get the possible zeros, you get the factors of the constant term, which is going to be 10, and you're going to divide it by the factors of the highest degree coefficient. Well, here's the highest degree, and here's the coefficient. It's 1. So we're going to divide by the factors of leading coefficient. So this is going to be factors of the constant term are 10, right? We have 10 and 1. That makes 10, right? We're talking about 10. The constant term is 10. So what are factors of 10? 10 times 1, right? We have 2 times 5, and that's it. You had to remember that pluses and minuses work for all of these. You could have had -10 times 1, and that'd be -10. Or -10 and -1, and that'll be -10. +10. But just keep in mind that plus and minus work for all of these. Then you have the leading coefficient on the bottom. The leading coefficient is 1, because that's the coefficient of the term with the highest degree. So now you have plus or minus 1 on the bottom. 1 times 1 is 1, And that's all we have. Therefore, the possible zeros for number 1 are plus or minus 10, plus or minus 1, plus or minus 2, and plus or minus 5. All right. So next up we have number 2. Number 2 says, a polynomial function g of x with integer coefficients has a leading coefficient of -5 and a constant term of 3. So the leading coefficient is -5 and the constant is 3. According to the rational root theorem, which of the following are possible roots for g of x? Well, you would use this formula, the same one, to figure it out. So you could say, okay, factors of the constant. We're talking about factors of 3. So you have plus or minus, we have 3, 1, that's it. What about the -5? Well, that's plus or minus 1, 5, that's it. So this could be anything like the following. 3 could be over 1, right? And it's plus or minus, or it could be over 5. And the 1 could be over 1, or it could be over 5. And so your possible answers are plus or minus 3, plus or minus 3 over 5, plus or minus 1, and plus or minus 1/5. All right, number 5, or getting ahead of myself, number 3. Number 3 says, state the possible rational roots for the function below. Well, we're going to take the constant term, which is 4, and divide it by the leading coefficient, which is 3. And so you could see the answers would be plus or minus, it'd be 1 times 4 and 2 times 2. Here would be 1 times 3. So these are all factors. Your possible answers are therefore, we have 1 over 1, which is 1, so plus or minus 1. We have 1 over 3, so that is 1/3. We have 4 over 1, which is 4. We have 4 over 3. We have 2 over 1. And we have 2 over 3. So there you have it. Number 4. Use the polynomial below for the next 4 questions. Identify all possible roots. So this is the same thing, and it just keeps going. Number 4 is the same. Number 5. Use synthetic division to evaluate the function at x equals 1. So the function they're talking about is this one. Notice that this is in standard form and it does not skip any degree. Right? Here's the degree of 3, 2, 1, none. So therefore, it's nothing really tricky about this one. We just write down the coefficients. The coefficient here is 1. Here is -8, 19, and -12. 1, -8, 19, -12. We're going to divide that by, it says, you're going to evaluate at x is 1. When you evaluate at x is 1, you just put a 1 here. This is whatever x is. So I know people get confused when they say, oh, this function divided by x minus 1. Well, then what is x? Where are you evaluating this at? Well, x minus 1 is 0, because we're looking for the zeros, when x is 1. So therefore here you will put 1. You do not put x minus 1 there. You put 1. Whatever x is, that's what you put here. Now, I'm going to bring the 1 downtown, multiply it by this 1 to get 1 here. 1 minus 8 is -7. Multiplied by 1 gives me -7 plus 19 is positive 12. Times 1 gives me 12, and if you add them, you get 0. That is your remainder. Because you got a remainder of 0, this indicates that x minus 1 is a factor of the polynomial. So, to answer the question on number 5, what is the function evaluated when x is 1? That's 0. As you can see, the remainder is 0. So therefore, the function there will be 0. It will cross, right? If this was 1, it crosses here. And so the height is 0. Number 6. Identify the other two real zeros. So basically we have this function. Now we know that if we divide it by x, x minus 1, we get 0, right? We get our f of 1, which is 0. Now, we also know that this is a factor. So therefore, x minus 1 times something else is equal to this polynomial. So it's asking what are the other, what's the remaining part here? What is here? Well, that's what you got when you divided this piece here. You will have, because this was x cubed and you're just taking away an x, you're going to be left with an x squared. You're dividing by something with an x. So you're taking that out. So you have x squared minus 7x plus 12 as the quotient. This is the quotient. Right? In other words, if you have x minus 1, right, you're doing long division, and this is your p of x, the quotient will be 1, negative 7, 12. That will be your quotient. And the remainder will be 0. So now the question is asking, it's saying, identify the other two real zeros. Well, we know the 0 for this one. We don't know it for these. Right? Because we know that these multiplied together equal this one. Just like 10 divided by 2 is 5. We know that these multiply together to equal this one. So I'm asking, what are the zeros here? Because we don't know them. We identified the zeros here. We now need to do this part. So x squared minus 7x plus 12 equals 0. Where does it equal 0? For what x values? Let's find out. Here we have 1 times 12 is 12, and our b value is negative 7. 3 times 4 will give you 12. Negative 3 times negative 4 gives you 12. And negative 3 minus 4 gives you negative 7. So this works. X minus 3 times x minus 7. We don't have to split the negative 7x into two terms here because the a value is positive. The a value is 1. Sorry. The a is 1. That's why. If it was not 1, we would need to split this b value. Okay. So, to answer the question, right? So far we know that this is equal to this. And so we have, if what x values would make this true? Well, it would definitely be 0 if this was equal to 0, because 0 times anything will be 0. So we have x minus 3 is 0, and so therefore x is 3. That's a 0. And if this was 0, then that would also work, because 0 times anything else is still 0. X minus 4 is 0, x is 4. So there you have it. Number 7 says to write the function in factored form. Well, at first we had an x minus 1, right? Here it is. And there it is. Remember they said x was 1, so therefore you have a factor of x minus 1, because if you set that equal to 0, you get what you had. So here's an x minus 1. As you can see, here's the x minus 1. And what were the factors for these? What was the zeros? Well, these were these two factors. So x minus 3, x minus 4, and we're done. That is your whole function factored out. Number 8. Use the polynomial test for the next 3 questions. The polynomial, okay. So we have 1, 4, 1, negative 6. 1, 4, 1, negative 6. It says to find the 3 real zeros using synthetic division and listing them from least to greatest. Okay. So here they don't give us anything. We need to use the rational root theorem, right? So we're going to take that constant and divide it by that leading coefficient, -6/1, making sure that they're both plus and minuses and accounting for all factors. We have plus or minus 1 times 6 gives you 6, 2 times 3 gives you 6. That's about it. Plus or minus 1 times 1 gives you 1. So therefore, these are your only answers. Everything's over 1, so it's plus or minus 6, or least to greatest. Plus or minus, we have 1, 2, 3, and 6. My goodness. Hey, let's try 1. Let's try 1. Let's see if that works. It's either positive or minus 1, positive or -2, right? These are all positive or negatives. Let's try positive 1. See what we get. Not all of them will work, but as you can see, we have up to 3 zeros. Up to 3 zeros. And these are the candidates. These are possible. Not guarantee. Right? I believe you're guaranteed at least 1. Let me double check. Nope, they're all here. Well, all here. Okay. These are all possible, but they're all there. So you're going to be a winner if you try them all. Let's try 1. 1, right? This is my first coefficient. The next one is a 4, 1, and a -6. Bring it downtown. 1 times 1 gives you 1. Plus 4 is 5 times 1 is 5. 6, 6, 0 is, this is a definitely a 0. So 0 is x is 1. Perfect. How do we know that? Remainder 0. From there, it gets easier because once you find 1, this is your new polynomial. It's much smaller. Instead of 3, instead of to the power of 3, you're going to have it to the power of 2. So now you're just working with this one. And you're trying to figure out the zeros there. Now your constant over leading coefficient is 6/1. So it's plus or minus 1, 6, 2, and 3. I guess that's the same thing. But, I mean, it should, in theory, get more simple. Now, let's try, I'm going to give it to you, okay? The next ones are x is -3 and x is -2. So for these two values, the remainder is 0. Number 9. You just got to keep testing it out, making until you get the remainder 0 for one of them. Number 9, determine the end behavior of the polynomial. Easy peasy. Here we have the polynomial. It's a cubic function, right? And it's positive. So I'm going to write that. Cubic, positive. Well, that looks like x cubed, which looks like this. So this is the end behavior. It goes like this and this. That's your answer. Number 10. What is that y-intercept into your answer as a coordinate point? Y-intercept of that function happens when x is 0, right? So as you can see from this graph, right? Let's say that was my graph. Well, you would get the y-intercept here when your x value is not when it's 5, not when it's -5, but when it's 0. That's when you get your y-intercept. So therefore, you have f of 0, if you plug it in, you get -6. So your y-intercept is 0, -6. Number 11, sketch the graph below in your notebook. All right. It should be one that follows all the rules. It has to have this as the y-intercept. It has to have the zeros of -1, +1, -2, and -3. And so I think you could figure that out. Should look like, here's one at -6. There's a y-intercept there. Here's 1, -2, and -3. Right? And then your graph has an end behavior like this. Right? So it should go like this, this, and this. Okay? And that's your graph. And it looks like that's it. All right, guys. Thank you for sticking with me. I know that these lessons are pretty long, but they're very informative, and I really hope you're learning from them. All right. That's all for today. Take care, everybody.